तो फिर स्टार्ट करते हैं पूरा। पिछली क्लास में हम लोगों ने प्रोटोकॉल्स की बात पर स्टार्ट किया था और एसपीआई प्रोटोकॉल के बारे में विस्तार से बात हुई थी। एसपीआई प्रोटोकॉल क्या है, उसमें हम लोगों ने देखा था कि प्रोटोकॉल 4 वायर प्रोटोकॉल सिस्टम है जिसमें सिंगल मास्टर और मल्टीपल स्लेव्स यूज हो सकते हैं। क्लॉक यूज होती है एसपीआई में जिसका रोल सिंक्रोनाइजेशन करने का है। तो फर्स्ट ऑफ ऑल क्लॉक सेंड की जाती है मास्टर से स्लेव की ओर, एंड देन आफ्टर the initialization process starts. The communication between master and slave process is initiated. SPI is used for synchronous serial communication. The same synchronous serial communication is achieved through I2C also, but there is a difference between these two protocols. So, when we have talked about the SPI protocols, we have discussed in detail about the functionality of how the master works, how the master initiates. Master initiate the process by sending the clock signals either on the rising edge or on the falling edge. The communication starts, sending of bits start between master and slave. And first of all, the MSB of the data bit is sent from master to slave. Similarly, if the slave wants to send the data back to master, then it has to be sent out by MISO pin and by sending the LSB first. So by using the MISO and MOSI lines, SPI achieved two-way communication, and it fast the total operation of communication. There are several advantages and disadvantages with the system also. We have discussed in this class. Here in SPI, we have discussed that single master is used, whereas there may be a slave, there may be more than a slave, and we have discussed in detail about how these slaves are selected to masters. There are different techniques such as daisy chaining and how these slaves are connected one after another. And then we have studied about the whole process of communication step by step. First of all, the clock signal is sent. Then after, the slave is selected by sending a low voltage signal to the slave. And then the actual data is transmitted to the slave by sending the MSB first. And if the system needs to check, verify that the signal or the data is received by the slave or not, Then the slave sends the data back to the master by sending LSB first. So this is the complete process of SPI. And so this protocol, we achieve several benefits. Benefits are that no start stop bits is needed here. So data can be transmitted continuously in either direction. The addressing system is not as complicated as the I2C. Higher transfer rate is achieved than I2C, as the data is transmitted continuously. As two separate lines are used, MISO and MSI, so both way communication is possible between master and slave. Apart from the advantages, this protocol or this communication process is also have some disadvantages too. Some of the disadvantages which we have discussed is that the physical structure is quite big in comparison to I2C or UART because it uses 4 nodes. And there is also a limitation that no separate bit is used to verify that the data which is sent is actually received by the slave owner. That will be correct. Means there is no acknowledgement bit or no parity bit like that, which verify the data source. So these are the limitations of SPI, and on the basis of these limitations, some other protocols are required. To replace SPI with respect to the physical space requirement, I2C comes in the picture. So when we talk about the I2C, in the previous lecture we have discussed that I2C is basically developed by Philips. To facilitate the functioning of their remote smoothly with the TV provided by the technician. It is using only 2 wires, so it requires less space. The cost is considerably reduced in I2C. So this revolutionized the serial communication procedure which is used earlier with SPI. Then we have discussed about the general principle involved in I2C. It is also a serial bus interface. And the most useful thing is that if we have several microcontrollers connected in my embedded system, which I am going to build, or in any project when you are going to use several microcontrollers, then SPI is not a feasible solution for transmission because it only supports a single master. So if several microcontrollers, 2 or 3 microcontrollers is connected in the system and all of them are wants to communicate with the memory, either to store or to receive the data from the memory, then SPI can't do it. You need another protocol. And then there comes I2C. Because I2C supports multi-master and slave system. So I2C is a very reliable parallel communication protocol for short distance transmission. Further, we have discussed about the various peripherals or various devices which uses I2C as their communication protocol procedure in which A to D converters, D to A converters, several sensors, memory devices, some I/O interfaces are very comfortable with I2C protocol while communicating using I2C protocol in their respective embedded system. Because I2C combines the various good features of SPI and UART, it is a very prominently used protocol in embedded system industry. So it is a very useful tool when we used multi microcontroller system to control to operate with several sensors interface with it. A2C protocol has two wire system. It only uses two wires, SDA and SCA, serial data line and serial. So here you can see that the single line is used for data transmission, which is known as serial data line. And the arrow shows in this diagram so that both the transmission, both way transmission take place on the single line. So at the same time, if you try to send and receive on the same line, it is not possible. So it reduces the speed of data. So if the constraint is that speed is not a major concern, then I2C is recommended over SPI. But if the speed is the significant role, it has to play significant role in the embedded system, then we go for SPI. The reduction in number of pins in comparison with parallel data transfer is evident here. As we look in this diagram, only 2 lines are used in place of 4 lines in SPI. So the production cost is reduced, considerably reduced, packaging size is reduced, and the third important thing is power consumption. Power consumption is reduced considerably. So when we use a battery operated embedded system, this generates a very important parameter to choose between given protocols. So I2C, as it is very clear, it is a two-wire system, so it is also known as TWI, that is two-wire serial interface communication protocol procedure. Now we are going to study in detail about the functionality of different pins which is used in I2C, different steps used while communication take place using I2C protocol. So first of all, we are going to study about the pin or the line ST, serial data line. So this line or this wire is used for master as well as slave to send and receive data. Unlike SPI, where you have seen that MOSI and MISO2 separate lines are used for receiving and transmitting the data, either from master or from slave, they are using two different lines for sending the data. Here in the case of I2C, the same line, the same as DA line is used to transmit the data in either direction. SCL, serial clock, this line is used to carry the clock signal, which is used to synchronize the data transmission between these two. I2C is a serial communication protocol. So data is transmitted bit by bit along the serial. The wire is SDA, and as it is a serial communication protocol, so the data is transmitted bit by one bit after one. Like SPI, I2C is synchronous as it uses a clock signal, so it's also synchronous protocol. So the output of bits is synchronized to the sampling of bits by a clock signal shared between the master and the slave. Means the clock is used here to synchronize and to synchronize between whom? Between master and slave. So until the synchronization take place, the transmission cannot take place. The transmission or reception is not going to take place between master and slave. So the clock signal is always here controlled by master. Master is controlling the clock signal, as in the case of SPI also. So if we talk about the characteristic features or the characteristics of the I2C, first of all, the differences comes in the wires used in I2C. Here you see that only 2 wires are used in place of 4, as in the case of SPI. So the physical space requirement of I2C is reduced. I2C works in various speed mode. It operates in standard modes of 100 kbps. It has a mode of fast mode which operates in 400 kbps. And it has the maximum speed configuration of 5 Mbps, which is known as ultra fast mode. In all, it has 4 modes of operation. This is a synchronous protocol, as we have seen that it uses clock signal, like as SPI. The data transmission takes place on the single line, and that is serial bit by bit. Here, again, a very significant difference comes in comparison to SPI, that number of masters, which is limited, which is 1 in case of SPI. Now here it is 1. And the number of slaves is increased drastically. That is 1008. So there are significant differences between I2C and SPI in their physical structure as well as in their working mode also. Now we see that how I2C protocol works, how the communication based on I2C protocol works. With I2C, data is transferred in messages. Messages broken up into frames of data. So in the first line, again, there is a difference in the working procedure with SPI. In SPI, we have seen that once the clock signal synchronizes, the data can be transmitted consistently, without interruption, without break. Here, what we see is that the data is transferred in form of message, and message is broken into frames of data. Means data is transferred here in form of frames, frame after frame. Here, each message has an address frame. Means that address frame decides which of the slave is going to be used. That address frame signifies the address of that particular slave. And then after one or more data frames, it contains the data being transmitted. Means the message has 2 things. One is address of the slave, and other is the data which is to be transmitted to that particular slave. The message also includes start and stop conditions, read write bits, acknowledgement, no acknowledgement bits between each step. The message also here have start and stop condition, whether it is to be read or whether it is to be write, and there is a acknowledgement bit also, which is missing in case of this. So if we see the message format or in the data format, there is a considerable change in case of SPI and I2C. In the case of SPI, there is no definite frame, no definite structure. It only says that whenever the signal is, whenever the clocks synchronize the operation, that is the operation between master and slave, the data is transmitted from master to the slave or from the slave to the master continuously. Here it is not the same. Here the message have start and stop conditions, read write bits, acknowledgement bits between each data frame. So in this protocol, the user can easily identify whether the data sent to the slave is actually received in the correct form or not after sending the each data. So the necessity of reading the data back from slave to the master in case of SPI is eliminated by just checking the acknowledgement bit. So this is the frame. The frame has a start bit. It is having an address of 7 or 10 bits. Then it can contain a read or write bit. Then a single bit is there to acknowledge whether the data is received or not. Then the data frame, that is the first frame of data, that is of 8 bit is sent. Again there is acknowledgement bit. Again the second frame is sent. And likewise this process takes place until the stop bit is sent to terminate the transmission. So start bit is sent to initiate the operation. Then the address bit is sent to choose the send display. Then a read or write bit is sent to either receive or send the data. Then acknowledgement bit is there whether the data is actually received or received or transmitted by slave. And then after the data, which actual data, whether it is to be write or read from the slave, depending on the user taking frame after frame. So the start condition, what is the role of the start bit? Here the SDA line switches from a high voltage level to a low voltage level before the SCA line switches from it. So the SDA line sends a high voltage to a low voltage signal before sending an SCA line from high to low, which only used to indicate that now the master wants to receive the with certain slave. Yet the slave is not decided in this particular step. The stop condition is the reverse condition of the start condition, which only indicates that now the whole operation is going to be terminated. The operation, which is to be either read or write something in the slave, is over, and now the operation is going to be terminated. So this bit is used for that. That is stop condition. Address frame has the address of the particular slave, which is identified, whom which the master wants to talk to send the data. Read and write bit is used whether the master is trying to send the data to the slave or requesting data from the slave. So if master have to send data right into the particular slave or to send the data to the slave, it sends a low voltage level signal at that bit. If the master wants certain data from the slave, then it sends a high voltage level signal at that. Each frame in a message is followed by an acknowledgement or no acknowledgement. If an address frame or data frame was successfully received, an ACK bit is returned to the sender from the receiving device. Vice versa means from either from both the sides, that is from master or to slave. If the data is sent from master and is successfully received by the slave, then slave send a acknowledge signal that the data is received. If the data is sent from the slave to the master, the master sends a acknowledge signal that data is successfully received. So this signal is sent by either by master or by slave, depending on the data transfer direction. This is the actual clock diagram for this data transmission. So first, an SDA line is set by sending a low voltage signal. And then after, we look in a CL clock cycle, you see that a CL is sending a 7-bit of address line after sending a start. Then the 8th bit is used for either read or write outputs. The 9th bit indicates that whether the data is successfully received or transmitted in either direction, and then the actual data frame, the first data frame of the message. And likewise, the same message can consist several data frames until the whole operation complete. So this is the format which is used in I2C. It consists of a start bit, an address frame of 7 to 10 bits, a read write bit, acknowledgement bit, and then the 8 bits of frame means the frame, the data frame is a 1 byte. It's a very important question. Can be asked in 1 marks question that how many bits are there in a data frame of I2C, and of how much, and the same in the same way, question may be asked that address frame has how many bits for addressing slaves. So these are 7 to 10 bits. So such questions may be asked in shorter version of questions that draw the frame structure, draw the message structure of I2C. Short answer. And if the question is asked on the long answer, then it must be like explain the I2C communication protocol in detail. Then you have not only to draw the I2C diagrams, its characteristics diagram, but also the frame diagram, which you have seen in these particular slides. And then after, the working procedure, which we discussed in the next slide. Addressing in I2C. This is a very important fact. That what is the addressing phenomena in I2C data transmission? And I2C does not have slave select lines like SP. As you have seen that only 2 lines are used, that is SDA and SCL, and no SSRCS line is used in I2C. Then how the addressing or a particular slave is identified in I2C protocol? As we have discussed, that in I2C protocol, the address bits that is of 7 to 10 bits decide which slave is going to be used. So from 7, we can know that how many slaves can be connected. It is 2 to the power 7, and the maximum number of slaves can be easily find out by using 2 to the power 10, that is 1048 slaves. And out of this 1048 slaves, which slave is going to be operated is decided by the message bits sent in the message, address bits sent in the message frame. So addressing is nothing but the identifying a slave. The address frame is always the first frame, the start bit in a. The master sends the address of the slave it wants to communicate with to every slave connected to it. मास्टर सभी स्लेव से कनेक्ट होना चाहता है, उसे कम्युनिकेट करना चाहता है। हर एक स्लेव का अपना एक एड्रेस है। तो जब भी मास्टर कोई मैसेज सेंड करता है तो उसमें सबसे स्टार्ट में एड्रेस फ्रेम होता है। उस एड्रेस फ्रेम को सारे ही स्लेव रीड करते हैं। जिस स्लेव का मैसेज उस मैसेज फ्रेम में भेजी गई बिट से उसका एड्रेस मैच करता है वो स्लेव एक्टिव हो जाता है। और जब वो एक्टिव हो जाता है तो वो एक लो वोल्टेज सेंड करता है, एक्नॉलेज सिग्नल, जो बताता है कि नाउ आई एम रेडी टू कम्युनिकेट विद द मास्टर। So this is the role of this first ACK bit. You see here that first of all a 7 to 10 bit of address is sent, then a read-write bit is sent to initiate that whether the data is transmitted from master or to read from slave. And then once the slave recognizes that the address sent by the master is his address, a match by his address, then that particular slave sends this acknowledgement. And after acknowledging, actual data transfer takes place. So once the signals are sent, once this phenomena is recognized, then the actual data transfer starts. So the rule of read-write bit here is to only say that the master wants to write the data to the slave or it wants to receive data from the. If the master wants to send data to the slave, the read-write bit is the low voltage level. And if the master is requesting data from the slave, then this bit is high. So 2-3 things is very important while communicating using I2C. First is the start bit. Second is the 7 or 10 bit that decides which of the slave is going to be used. Third is the recognition of whether the read operation or write operation is going to take place. And fourth one is the slave which knows that he has to operate with the master either for reception or for transmission. After all these functions, the actual data frame is now transmitted. Then comes the role of data framing transmission. So after the master detects the acknowledged bit from the slave, first data frame is ready to be sent. So data frame is always 8 bit long. It has a particular limit, particular specified width that it is up to 8 bit. And as like in the SPI, the most significant bit is sent first. So when a 8-bit data frame is sent, then again there is acknowledgement bit to verify that the frame has received successfully either master end or the slave end. So if the master is sending the data, the slave has to send the acknowledgement bit. And if the slave is sending the data, the master has to send the acknowledgement bit. After all of the data frame has been sent, the master sends a stop condition to the slave to halt the transmission. Once the data has been transmitted, means the operation is completed. एक बार डेटा ट्रांसमिशन जब हो गया, सारे डेटा फ्रेम सेंड हो गए, either from both the direction, that is either from master or from slave. तो अब एंड करने की बात है, एंड करने के लिए एक एंड सिग्नल जनरेट किया जाता है और उस एंड सिग्नल को, उस एंड बिट को, उस स्टॉप बिट को सेंड करने के बाद ये बताया जाता है, ये प्रदर्शित किया जाता है कि नाउ द डेटा ट्रांसमिशन थ्रू I2C प्रोटोकॉल इज ओवर, इज कंप्लीट. So this is the rules of all the bits which is used in message. The same procedure which we have discussed can now be easily seen step by step in the steps of I2C data transmission procedure. Here you can see that the master sends the start condition to every connected slave. By switching the SDA line from a high voltage level to a low voltage level, before switching the SDA line from high to low, means master is sending the signal to all the slaves and sending the signals at SDA line, which is indicating that now a data transmission is going to be started. The next thing is to recognize the slave on which the data is going to be transmitted. So in step number 2, the master sends this each slave an address of 7 to 10 bit, which is the address of one of the slaves. And all the slaves have to check whether the sent slave address is matched with its own slave, own address or not. Once the slave recognizes that the sent address is his own address, which is shown in this particular slide, and the last slave, slave number 3, has the address which is sent by the master, then the slave has to be send a signal which is defined as acknowledge signal, ACK signal. So in step number 3, each slave compares the address sent from the master to its own address. If the address match, now the slave returns an acknowledgement bit by pulling the SDA line low for 1. So, so in this slide, you can see in the slave number 3, a low voltage signal is generated through SDA line for single clock pulse that this particular address is of slave, and now slave is acknowledging that he is well aware that the now data transmission is going to be happen between master and slave number 3. In step number 4, we see that master either send or receive the data. This can only be defined by the read write. If the read bit is low, then master is sending the data. If bit is high, then receiver is, slave is sending data back to the master. So this way, the data frame is now available between slave and the master. You see in the diagram that all the data frames are sent to all the slaves, but only that slave is going to accept or send the data, which is activated during the address identification process. So this is the step number 4 of I2C protocol. After each data frame has been transferred, means all the data frame which is needed to be transferred between master and slave is transferred successfully. An acknowledgement bit is sent to the sender. It may be master, it may be slave, that the frames are successfully received. Now the process can be successfully terminated. So you can see again in this slide that after the transmission of data, slave 3 sends a low signal here, which suggests, which indicates as an acknowledged signals that now the operation is completed, can be completed successfully. In step number 6, now master wants to complete the data, complete this procedure. So a stop bit is sent by the master. It is not sent by the slave. It is only sent by the master. So here the slave, here the master sending a stop condition by sending a SCL high signal before switching SDA high, which indicates now that the overall data transmission in master and slave is completed successfully. Here you see in this diagram how a single master is connected with multiple slave in I2C. So if you are using a 7-bit address, total number of 128 unique addresses can be generated. 128 slaves can be connected through a single master if you are using a 7-bit address. If you are using a 10-bit address, then maximum number of 1024 slaves can be easily connected through single master. So by this way, multiple slaves are connected to single master by using a pull-up registers, which is having the magnitude of 4.7K or 10K. These registers are used to connect power supply to the lines SDA and SCL of I2C for connecting them to the microcontrollers. So this is the complete working procedure of I2C protocol. In the same way, multiple masters with multiple slave configuration can also be achieved, can also be connected. Here the masters, multiple microcontrollers can be used to connect with multiple number of slaves, and the slaves can be similarly connected to the multiple masters also. So the same slave can be connected with different microcontrollers, or you can say that the same sensor can be used by different microcontrollers in an embedded system. So this I2C protocol is very beneficial when it is used in multiprocessor system or multi-microcontroller system or any embedded system. So this is a diagram where you see that two masters and three slaves are connected. It's only a specific part of a communication. It may have more number of masters and more number of slaves. But due to the space consideration, I'm only showing you the limited portion of the transmission. But the things are very clear here. The two lines are used, that is SDA and SCL, for communicating between master and slave using I2C protocols. And both the lines are connected to the supply, power supply, using registers. So this is the I2C protocol. Now we are going to discuss about advantages and disadvantages of I2C. So when we are talking about the advantages of I2C, there is a lot of things about I2C which make it sound complicated protocols in comparison to SPI. And the first feature which make it more prominently amongst other protocol is the number of masters, the number of connected devices. Because here the more number of masters can be connected to slave, so it is easy to use I2C for larger or a bigger embedded system. So one of the advantage it has is that it only uses 2 bytes. So the complexity is very much reduced. Supports multiple masters and multiple slaves. Acknowledgement and no acknowledgement gives confirmation that each frame is transferred successfully. So unlike SPI, it also has a feature that shows whether the data is transferred successfully or not successfully. Hardware is less complicated, as we see that only 2 wires are used. So it is a well-known and widely used protocol which is used nowadays in different embedded systems. If we talk about the disadvantages of I2C, there are certainly every system has disadvantages. The system is an ideal one. There's also some lacunas. It also has some limitation. It also has some disadvantages. We have to figure out. The first one is the slower data transfer rate, because it only uses 2 wires and one is solely used for clock purpose. So it has only a single line for data transmission. So when you use single line for data transmission, data is transmission only in one direction, either from master to slave or from slave to master at all. So it reduces the speed of operation. The second major disadvantage is the data frame size. The data frame size in I2C protocol is of only 8 bits, is not a very big site. You have to reduce the data bits frame by frame if you have to transferring it. So for the larger system, which uses more than 8 bits of data transfer at a, at a single time or in a single specific time, then I2C is not feasible for that. Apart from only 2 lines, but if you see the whole hardware needed, then it is rather a complicated network because it uses full of registers, and naturally if more number of masters and slaves are connected, then it is not an easy thing to construct complete robust system. Very easily it cannot be constructed. So it is a rather a complicated hardware needed to implement a major embedded system using large number of masters and slaves. So all these things are on I2C protocol, which we have discussed today. In the next class, we will going to discuss about the UART, what is UART, how it works, how it is different from synchronous communication as it is a asynchronous communication procedure. So naturally, the operation is entirely different from SPI and I2C protocol because it won't need any clock signal to synchronize. That we will discuss in next class. As all these protocols are very important when you are fabricating, when you are going to fabricate or build a project in embedded system. So each of the protocols or each of the communication procedure is well known to you before implementing any project, so that you can well understand or well familiarize with all these things before going to implement any project which have a multi-processor or multi-sensor embedded system. So till now we have discussed only 2 protocols, that is SPI and I2C. And in the next class, we are going to discuss about the other protocols such as UART, CAN, USBs, and these connectors, which are used in fast and which are used in scenario also, like RS232, RS422, RS45. So they are used for purpose to be used in embedded system. So all of these things is going to be discussed in detail in the further lectures. So for today, this is all from my end. तो आज का लेक्चर हम लोग यहाँ पे समाप्त करेंगे. नेक्स्ट लेक्चर में हम लोग इसके आगे की बात करेंगे.